Okay, good afternoon, everybody. So as promised, this is the friction demo lab that I will be showing to you. And before we get into the lab experiment and the setup that I have decided to use to test for friction or give you an idea on what to investigate, we're just going to briefly go back through the lab experiment once more. So remember that friction is a force that is always working against motion. So depending on the object that you decide to test and the types of surfaces you decide to use and mass objects and so on, you will either take a look at how the object begins moving or how much force it takes for that object to continuously move either on a flat surface or on an inclined plane. Again, it's up to you. In the case of thinking about the concept of friction, within certain safety testing in terms of road safety, as well as in creating synthetic lubricants and things like that, such as places like an airport floor, your mall floor, at home on your wood floor, or tile in the kitchen, right? Friction is always considered in terms of these regards to safety, right? So what we're looking at is, okay, well, if we increase or decrease the coefficient of friction or the amount of frictional force on an object, how does that affect the object's motion in a general sense? So there are some situations where you will want friction, right, for safety, but there's other instances where friction is not required. So as you go through these different questions here on the page, what you want to keep in mind is right now, these first set of questions are just looking at different products that are designed to overcome friction that we use in everyday life or in the industry. But also think about the loss of energy that occurs by loss of heat to the environment, or as we say, from the system to the surroundings, from a physics perspective, where friction is involved. So as you go through these sheets, and I'll show you my design in a moment, you will be filling out this data table for our video. As well, after you're done doing that, we're going to go through 3 trials using 4 different types of materials. You can answer these pre-lab questions right on the sheet. So it'll give you some ideas as you start planning your own lab. And again, remember that friction is caused by the interface of the atoms or molecules of each object sliding over each other. So a rough surface will produce more friction than a smooth surface, but no matter how smooth surfaces may appear, they are rough on an atomic level, and when they rub, friction always produces some amount of heat, which is lost as unusable energy. So this is true just for the very basic example. If you take your hands, put them together and rub them, you'll start producing heat. So there is some sort of friction in between the molecules on the surface of your skin. Now, remember there's 2 types of friction that you can test for. The first type of friction is static friction. So that's friction between 2 objects that aren't moving. And then there's the kinetic friction, otherwise sometimes known as dynamic friction, where you're looking at friction between 2 moving objects. So when you think about designing your friction experiment, either you can test for both types of friction or you can test for one or the other. So I'm going to switch over to my friction experiment now. So I'm just going to change over the screen to the other side. And then you can see my laboratory setup. So let's see here. Okay, so we'll stop sharing the document. So here is the lab setup that I have for you. You might not be able to see all of my labels, so I'll just go through one by one and tell you about everything that I have for the demonstration. So I have a wooden block right here. So this wooden block weighs 241 grams. So we may or may not need that information. We also have a set of masses right here. and a hook and a stand for where the masses will go. This hook and stand is already set at 50 grams, so we are going to keep that in mind when we attach it to the wooden block. And each one of these discs of mass are 20 grams. So those are our objects, and the wooden block is what we're going to consider for the demo. In terms of the materials that we have here, so we have wood for the wooden table, so this will be the control that we compare everything to. We also have a vinyl placemat, which is, typical placemat that you would have for your dining room table, let's say. And then we also have sandpaper here. And I'm just going to go around to the other side. And the fourth material that we will test is going to be a piece of tile as well. So I'll just place the tile over top the sandpaper area once we are finished testing those. Okay, so we'll use this piece of tile back. Now, the rulers are just set up. So there's two rulers here. One ruler is here. Another ruler is right here. I just taped it down. Just so that we can see whether or not the object moves, if you are looking from a bird's eye view, if you're working with a partner. But in any case, you may already have some sort of hypothesis in your mind as to which particular surface we will test is going to have a lot of friction or no friction, right? Depending on the type of material we're investigating. Notice as well, with our wooden block here, that we have the block attached to a string, and this is the string that is going to simulate those questions where we looked at, a cart and a hanging mass, or a block and a hanging object, that type of stuff. So we're going to see when we set this up, let's say on the sandpaper versus the vinyl versus the wood, right? We're going to see whether or not this block is going to end up moving based on the hanging object. So when we set it up, you'll essentially see something like this. So you'll see this block, you'll see the hanging mass, hopefully you can see that on the screen. And then we are going to start adding these gold discs. So these gold discs here at 20 grams, one by one, to the hanging object. And we're going to see how many of these we can add at a time for the block to start moving, okay? And based on the number of mass that we add, or the quantity of mass, that will tell us, which surface has more friction or less friction, okay? And that's the information that we are going to record in the data table. So if you do have your data table with you, you can fill it out as you follow along. We're going to do 3 trials of each of these, so it will be quite lengthy. So we're going to end up doing everything total 12 times. But that way we can see what's happening in terms of the numbers, and so that our data makes sense in comparison to the wood tabletop versus the other 3 materials, right, with increased or decreased friction. With the vinyl tablecloth, the reason why, or the placemat, the reason why I picked this is because it has a texture on it. Similarly, so does the tile. It's somewhat of a granite tile or something, some sort of combination of that. So based on the rough surfaces versus the smooth surfaces, we'll see how that corresponds to the amount of friction that's involved. So let's get started with our trials of the experiment. So we will start first with wood, so that's the control, and then we'll go to vinyl, sandpaper, and then tile. But the idea is that we're going to add these masses onto the stand and see how much mass it takes for the block to move. So let's do that. So we'll start over here at wood. I'm just going to pull this block up a little bit more so that it lines up at 0. Okay. And you can see that, we have this system of a block sitting on the table and we have a hanging object, okay? And then we'll note down the given information. So I have my planning sheets here. So I'll keep that here. Let me just grab a pen. So that way I can write down all of this information. So I'm starting with wood, and I'm just recording how much mass I'm adding. So I'm just going to say, did I add 1, 2, 3? Because all of them are 20 grams. So we have wood, vinyl, the sandpaper, and the tile. Okay. And right now we already have started at 50 grams. Okay. So I'm just going to hold these all in my hand, and I'm going to attach the first mass right over here where the hook is. Okay, and we're going to see if there's any movement to the block. Okay. So far nothing if I look to the top. So that's 1, 2, and the block starts sliding. So I'm going to record 2 for my first tile. Right? And then you can see eventually, because of gravity as well, this block system is moving. So we take these off, and we can repeat the trial again, set back up our system. Okay. Now let's try again. So we already got 2 for the first one. Okay. I won't explain again. We'll just do this quickly. So trial 2, 1, 2, and the block starts moving. So again, I have 2. So that's about 40 grams extra to the 50. Okay, one more time. Okay. And just for variety, I'm going to pick some different ones. Okay. 1. And like this one wants to go. 2. And the block starts moving. So it is sliding slightly. If I look from my bird's eye view, the block has moved about 1 centimeter. Okay. So I guess all 3 of those trials were complete. Now we'll move our system over to the wooden block on vinyl. Okay. We'll set it up the same way. I'm going to do it away from that piece of paper as well. And then we'll talk a little bit about some sources of error in this lab, because I can already think of maybe 1 or 2. Okay. So again, same setup. We've got the block now on the new material of the vinyl placemat, and we're going to go through the exact same procedure, okay? And remember that when you outline your lab, you're going to write out the steps that you will take to conduct your experiment. So again, I don't know how many of these discs are going to be required, right? But maybe there's going to be a little bit more traction compared to the tabletop. So let's see. All right, and hopefully you can see what's happening as well. So let's start by adding 1. So far, nothing. 2. And the block starts moving. So we're going to write down 2. So interesting. Okay. Again, next trial. Right. Line everything back up. Put my mask back on. Right now everything is at rest. Now I'm going to see when the block's going to move again. 1, 2, and the block starts sliding, as you can see. Hopefully not off the table. So again, it's 2. One more trial. And you'll notice that this one moves slightly faster compared to the table as well. So those are some qualitative observations you would be making. Okay. 1, 2. Okay, not really any movement. 3. And now the block continues to move. I just want to stop it before it falls. Okay. Now onto the sandpaper, same process. So we're going to put the block on the sandpaper, line it up, so I'm not blocking. We're going to line it up to the top of the ruler. And you might already have an idea, maybe it's going to take more mass this time. So let me just take everything with me over to the other side of the table. Okay. And let's continue. So again, 3 trials, this time for the sandpaper. All right. And we don't have to worry about how far the block moves. We're only interested in when it starts to move based on the mass that we add. Okay. So 1, 2, so far nothing. 3, 4, 5, 6, 7, 8. So now the block started to move. So we're going to write down 8 for sandpaper. And then again, take everything off, start again. Okay, line it back up on your desk or your table. Okay, there we go. So let's go. So the first trial gave us 8, so maybe it should be around 7, 8, or 9. Let's see. 1. Oops, come on. 2. This string is not visible. 3. 4. 5. 6. 7. So this time it's starting to move at 7 a little. So a little bit of a slide. All right, one more time. Sorry, this takes a little time. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Sorry about that. And 9. So it started to move at 9. Interesting. Trial with sandpaper, and then finally our tile. So just going to remove the sandpaper from this area here. I just had some tape to secure the sandpaper in place. And hopefully this is giving you some ideas on what you'd like to test. So here I'm going to put my block of tile. This is the tile from the kitchen upstairs. Okay, and hopefully we don't have anything break, but let's see. So remember safety. Let's remove everything. And set up our APM once more. When I was talking about those different sources of error in the experiment, maybe one source of error you might already have come across or been thinking about was that this surface of the table is wooden, while the top portion here is the object or the material we're interested in. So maybe this both has a factor as this is hanging off the edge, so we don't have a straight edge, right? So there is some contact between the string and the hanging object. As you can see, the string is hitting the table right here. Another source of error might also be that if you're not consistent with who's actually watching what's happening, maybe there could be some slight discrepancies in these masses or even in the surface of the block itself, because it's not a perfectly smooth block. It does have, I don't know, for some reason it has some staples on it on one side, but I'm not using that side. But it does have some notches, so it's not perfectly level as well. So that could also have an effect on the friction of the system and the motion of the block itself. So with our final trial here, or final material, 3 more trials to go of tile. We'll see how the tile compares to the rest. Okay? So let's see, we're going to add 1, 2, 3. So 3 of them for the block to encounter some extreme motion. Okay, let's go again. 2 more trials, and then we're all done with our data collection. Okay. 1, 2. So this side of the block moves at 2. Okay. Once more. One. Okay, that's okay. 2, and it starts going. So there you have it. So we have all of the data that's required, as you can see, and we filled out the table. Okay. So in terms of the pre-lab questions that are on the page right over there, right, as you could see, and the sign was kind of backwards. But let's go to what we were investigating. So when I was thinking about my design or my ideas behind my lab, the ideas that I had that I wanted to test were how much mass it will take to get the block moving, as well as how do different surfaces and mass together affect the motion of an object and the force of friction it experiences. So is there an increase or decrease in friction or motion for the object? Now my object is the wooden block, as I mentioned. So I wrote down a list of some of the materials I needed, or I thought I would need. So the wooden block, I know the mass of it. And then I have my different surfaces, the wood table, the vinyl placemat, sandpaper, and tile. I had my weights. Each weight is 20 grams. The holder is 50, and they're all labeled. And then the rulers and some tape just to secure the placemat and the sandpaper. Remember that I mentioned the ruler is used just to see whether or not the block moves, not how far it moves. If you're interested in looking at the distance component as well and how that relates, you could also study that if you like. Maybe that's also a variable. And then I had my data table where I compared the tile, sandpaper, vinyl, and wood and I did 3 trials of each experiment, and I filled that out. So I'll post up the demo for you, but if you're following along with the lab, hopefully you filled out your table while we were experimenting together. Think about the post-lab questions as well. What materials will be available to you? I will post a list and some pictures of some of the stuff I have over at school in the class tomorrow morning, so that way you can take a look and see what you and your partner might like to use for this investigation or not, right? You don't have to use a wooden block and hanging masses like I did. You could use an empty box or container and have that attached to another empty box or container or a Dixie cup or something. And then you can add rocks to it. You could add pebbles to it, marbles, what have you, pennies. You know, if you want to bring some pennies from home, if you still have those lying around, since we can't really use them in the store. Likewise, you can also bring in some of your own surface materials as well. So I used dry materials, as you noticed. I didn't use oil or water or any kind of spray. But if you're interested in using oil surfaces and things like that in class as part of your experiment, you definitely are welcome to. It is your experiment. Remember, you're designing it. So when you take a look at your results at the end of the lab, think about what some extraneous variables could have influenced your results, how you could modify your experiment to make it better or test something different. Talk about if you were testing static versus kinetic energy and friction, explain how you would have known that. And also describe how you could change your procedure to remove any extraneous variables or anything which would cause sources of error. Okay, so that's it for the demo. Hopefully you enjoyed that little investigation that I conducted here in my basement. And I'll see you in class. If you have any questions, please email or message me. Remember, Cohort B, you will be conducting this experiment at school this week when you come on your day. I believe it's Thursday. Wednesday or Thursday, I don't remember the schedule, but whenever you come to school, you'll be investigating and conducting your lab. So please have everything outlined before you come to class this week so you can do your lab. Otherwise, you're going to have to gather the materials and do the lab at home. And for Cohort A, you will be conducting the lab at school with me on October 5th, so that's next Monday. Okay. So again, I will also post some other examples of other teachers and students testing for friction in the lab. They may have not done it the same way I did, but at least it will give you some ideas as to what you might want to do as well. Okay? Thank you and take care.